miles of wires that we have there. But we need something in between. We need something that will read our data and send it out. So everything you see in that square is a coin-operated machine. And outside the square is our Drupal database. But we know what to put now in the question mark. But still, we have an issue. So now we replace IoT with question mark, but we still don't know what IoT is and how to build it and what to do with it. You know, it's a buzzword lately, but still, how to actually do something from it. And to know what IoT is, we need to go through some definitions. And this is what Wikipedia tells you about IoT, that it's pretty much a physical object, usually with some sensors, processing powers, and other technologies, which is connected with the internet. And you might think, you might question yourself why there's a toilet, or actually a smart toilet there. It's because someone had fun before us, and if you visit Wikipedia, Internet of Things page, the first image you see there is the smart toilet. So we know what IoT is, and now we need to put it where the question mark was. Sorry, wrong image. Something like this. So we need an IoT device that we need to put in between of a coin-op machine and Drupal. But still, we're far away from our solution. And thanks to expressive systems, now we have modules that are really cheap, accessible to everyone, easy to program pretty much. You probably use them in most of your devices at home. If you have some smart switches, smart slides, this is what's inside. If it has Bluetooth, it's the one below. If it doesn't, it's usually the one on top. Not the whole thing, just the IC on it. They're small, they're powerful. Wi-Fi is integrated, very low price. And the ESP, so this is for ESP8266, ESP32 has also dual cores, so 2 cores, 2 CPUs, and 2 CPU cores, and Bluetooth, and more GPUs. But for my example here, I use the ESP8266 because it was cheaper, and I didn't need the Bluetooth because I just wanted to have my device connected to the internet. So I decided to go with a more powerful board, if I can use that word. It's actually, it has more IOs than the one on top. It has a nice feature that you can connect it to the micro USB and program it, also power it with 5 volts. It has UART on both boards, so you don't need to have an extra USB device to program it. It has everything there. It's the little chip, the IC on the right, the black one. Though the main thing is here you see on the left side with the integrated antenna. This is the ESP, the expressive ESP IC board. And it has a reset switch, a LED light on it we can use in our codes. It's a really nice programming board that actually can use it for some production stuff. So the next component I need to introduce is an electronic coin acceptor. I use Comestero RM5. It also depends how the coin is inserted, where it goes in, where it goes out. It either falls down or falls at the side. What a coin acceptor is, especially electronic coin acceptor, is a device which recognizes the coins by using electromagnets. It weights them, it checks the size, it checks if the material is right, and then decides if this is something that it will accept or not. And after doing some research, we will not go too much into details. You have the documentation for every device, and what I needed to understand are the pinouts, where to get the power. The 12 volts is what you get in, so we can probably take the 12 volts and power our device. And we need to understand how to program it. Especially if you program it for euro, we need to set the values, the credit per value. So if you put in €1, you decide this is 1 credit or 2 credits, and so on. So this is what you program, and then you connect to it, and you start reading. This is how the data looks. So it might be fancy here, but pretty much just try it out. You check every channel, you throw the coins in, you see which channel is the right one for you. The right channel was channel 3, which this image proves. and every time the level changes, you get credit pretty much, and the time in between is a time also that can be also set in the setting for the coin acceptor. Usually it's 200 or 200 milliseconds, because if you click it too quick, sometimes the device, the coin operating machine on the other end, cannot recognize that there were 3 clicks. They can recognize it as one. So you need to have some spaces in milliseconds in between. This example is if you put like one and those are 3 signals here, it would actually mean that you put in 1.5 euros. In our example, where we set it up to 50 cents per credit. Okay, so the next thing. So now we know the devices. We need to start putting some schematics together. This is a really probably not the best thing to show. I found an old drawing. It's not the first one, but it's probably not the last one. So just for easy representation, this is where you place our IoT. It's not the full IoT device, just the chip that we're going to use. So the IoT device is everything together. And we needed to know where to read the channels. We needed to put some transistors to make some switching logic, and then power it down from 12 volts to 5 volts. This is why we use buck converter in the middle, a couple of resistors, but pretty much it's not really that complicated. And this is what I came up with. I have it with me. This is the IoT device, the prototype, which works. We have WiMOS D1 on it. We have 16-pin socket under it, which we basically, it's a good thing to have because we can easily replace. We don't need to program the whole thing. We just program the ESP, bring it on, and place it on the chip. So it's pretty much like this. You can put it apart. There's a transistor with the right one, which we needed for our logic, and a diode, some resistors, the 10-pin ribbon cable we use for our daisy chain connection, dip switch for our 4 channels, but we always use 3. But in case some machine is set up differently, we can switch the channel, even though usually we just stay on 3. And a micro switch, which comes really handy because we can program it. So we can program something on the boot if you have it pressed, or if you press it once or twice during the power on. So this is how the board looks, and now the fun part is over. We'll have to switch to coding. We have the PCB assembled. We know how to read the data, and we're just left to put the code on our IoT device, because this device is empty. It doesn't have any firmware, and you need to program something on top of it to actually make it work. And for the ESP, you have pretty much a chance to choose one of the 4 languages: MicroPython, Lua, Arduino, or C++. If you're working on that, pretty much all are quite well supported. I started with Arduino and also used Arduino before, and then in Arduino IDE is a cool tool, but then I wanted more and I switched to C++, has more libraries and also really good support. So I said, okay, I'm gonna do it in C++ and whatever is, and yeah, and this is how you start. You need to have an IDE, and a really good one is an extension for your existing IDE. Actually, is Platformio. It supports many IDEs. You see them listed below. I used Visual Studio, though I'm on PHP Storm, so Sea Lion would be kind of the closest one to me for me, but Visual Studio, I said, okay, it's really good support. It's basically the first thing you see if you go to the download page, and I said, okay, I'll go with it. And as soon as you install it, it asks you about your create new project. It asks you about your board, and it has pretty much, I think, all the boards listed that you need. So everything you'll find on the internet, you will find it here to select. And I was able to select WiMOS D1. And as soon as you select WiMOS D1, it shows you an example. So pretty much in like 5 minutes, you get to this page. You have this device. You install the IDE extension. You select your device that you have in hand, and you get the example, which pretty much just blinks your light. And this is what you need to start, because you need to start in small steps. And as soon as you see something blinking on your device, it's a really good feeling, and it's just just motivates you to do more. And in practice, you connect it with your USB cable, USB to micro USB, and then on the screen you see the build and then the upload. So pretty much you press build, it builds your app, and this is still the default code. There is no line that I had to write at this point, and the device was already blinking. Okay, so you know now it's working. Now you have to go to the custom code, which is a bit more complex thing. You need to include more libraries. You need to actually, have some idea, some logic what your app is going to do. And this is what I'll present in the notable features in coding. So the Wi-Fi connection, of course, without it, you cannot connect your device to the internet. You need some configuration because we need because we have those devices on multiple machines, and every machine has an own idea. So we need a configuration on each specific module, on each specific IoT device. So we need to serve some HTML form and show it to the user. Otherwise, you would need to put everything on every device, pretty much connect it for every device, put the ID, and pretty much hard code it in. But with because you have configuration, you have little fs, which is a lightweight file storage to store the configuration. You can do it without actually hard coding your configuration on every specific device. So another notable features is less stateless light. It blinks. I'll explain later, but it's a really nice feature. Posting data to API server, pretty much the most important thing. Posting ping on boot, which is a good thing to have if you want to know when your device boots up, or also for some debugging. And setup and loop are the two main functions. So after you set everything up, the variables in code, you have a setup, which sets the boot state. It serves the HTML pages, posts the ping signal, because we know that happened once. And on loop, it actually loops and waits for interrupts infinitely. So pretty much every device like this is just waiting for something to happen. So you have a smart switch, it just stays in this loop forever. And when you press something, it recognizes this interrupt and reacts to it. So for us as Drupal developers, it's kind of weird that something loops infinitely, but this is how those devices work. They're just waiting for something to happen. Okay, so the Wi-Fi connection. A notable thing about Wi-Fi connection here is that you see an if and else if. So if you boot your device, pressing the button down, it goes into the AP mode, and you set up your internet connection. You set up your SSID there. If you don't press the button, it tries to load the SSIDs from the configuration. So pretty much this is it. It's a good thing if you move the device or you want to change the SSID. So it's a good thing to have a button, so you have a chance to boot the device in different modes. The configuration, this is how it looks. It's an ugly HTML that you serve, but you can show the current variables that you load from the configuration. So in case you put the device and check what the current settings are, you see the settings that are currently on there, and you can change them. By changing them, you call the handle form submit function. And the main thing there is the store config line, the one at the bottom, the third one from the bottom up. It stores your configuration in a small file system on the ESP, which is 4 megabytes. And you can store quite a lot of key value pairs for that. So this is where I'm explaining this. You have the prepare FS function, which formats your file system and gets it ready to be able to read and write from the files. Store config functions is the one I described before. It pretty much reads the file and prints the output, prints your arguments, your parameters of the functions into that file. It's perfect for storing configuration, and as I mentioned before, it's 4 megabytes, but it really depends on the device. So our device has 4 megabytes, but you can also connect SD cards with modules and so on. The LED light, very simple functions. Signal with LED is where you can see, I'll just describe briefly the digital write, what it does. So whenever you decide to put something on, you go with low, and then when you want to turn something off, you go with high. So the LED variable here is defined in the variable section on top of the code. It pretty much defines which ID, the output ID or the I/O, handles the LED diode, and that's on the device. And you have the delay time on, so that means how many seconds or milliseconds this LED will be on. You see signal with that 150. It means that this is the delay. And in our case, when I'm calling LED OK, it blinks twice. When I'm calling LED error, it blinks 3 times. This is good to read the data, what we get back. So I used it in the post return. And in case we get 201 created from Drupal, it means that it created a new node for us, and it will blink twice. If that is all good, if we didn't get any errors. So the post data, straight from day one, I started using the SSL for secure connection on port 443. The Wi-Fi client secure is one of the libraries that's used for that, but it's now something new. I think it's called Wi-Fi pair client secure or something like that. That's why the verify function is underlined, because I updated the code and immediately recognized this function is not supported anymore, so it needs to be set fingerprint right now. So this code needs to be updated. But to explain briefly, it just tries to verify the fingerprint which you get from the server website. You generate this fingerprint, the SHA, and it verifies if the client verifies if that fingerprint is right, so it knows that it talks with the right server. And of course, there are cons to that, because fingerprint is not the best thing. If you change this, the certificate, you have issues. I read just a couple of days ago that we might have issues with our refrigerators and other devices that are connected with the internet, because they use a root certificate, which will expire in 25 years. So in the next 25 years, we'll probably all have to upgrade our firmware for all those devices in case they're using the SSL connection. Hopefully they do. So this is about the coding part. Now we switch on the C++. Now we switch to Drupal, and whoever used the API in core probably know that those are the modules you need to enable. Some for serialization, and you have UI for the main one is RESTful web services UI to actually click the resources you need. And we try to get something like this. The client will be replaced with our IoT device. We will not use get, put, and delete, so we will cross it out. We will just use post, because our decision was to just post the data from this device to the server. We're not getting anything back, or we're not changing the existing data. So the configuration, as soon as you enable those modules, you'll have this URL available in the administration configuration, and the REST API for node, the content type, is basically the node entity, is already there. So we're not creating a new one. We'll just enable one, because our plan is to keep it simple here, and we just stick with content types. We use nodes. It has what we need. It has titles. We can add fields. So we didn't create a custom entity, even though we could. We just enable this resource, and as you can see, it crossed get, patch, and delete, so we just use post. And we'll use JSON for the output. So the content types, we have a couple of content types for our needs. The one that's where we saw it is the machine. It has a title, description, and type. So every coin-op machine is titled, it has a name, if this is a Dart machine, or it's a coffee machine, or it's some pinball machine with a specific name. It has a description, not mandatory, of course, and a type. If this is, for example, we can separate them between the types like coffee or vending machine or amusement machine, whatever. It has a location. So we have a location which usually has a title. Maybe it's called some kind of bar, and it has an address. We have a ping content type, which it's good for some debugging. Every time the device boots, it will actually call our server, so it will tell about its machine, where it's currently is installed, the IP, and the IoT firmware version. Because we have in C++ custom code, we have versioning, so it's good to know whenever the device boots to report its version, in case in the future we need to update it. And then the event is underlined. It's pretty much the main type. It stores the number of clicks, the value per click, the machine, and its location. So number of clicks means how many times the coin validator send out the signal out. So send out the signal. It's how many clicks it did. So if we set it up to 50 cents and you put in €1, it will do 2 clicks. If you put €2, it will do 4 clicks. And then the value per click is the one which we define on the coin validator. So we don't say you put in €2 whenever you put €2. We say you put 4 clicks and value per click is 50 cents. And every of course event needs to know about which machine is sending and from which location. And placement is a really nice thing to have, because as soon as I started developing that, on every IoT device, I had to configure where is it placed, because if you change the machine, and its location, you had to then go into the configuration, change the location, even though the module is still on the same machine. So placement is a good entity because we store the time where it was placed and date when it was removed from a specific location. Why this is good is because, let's say we have a coffee machine and it's on one specific location and it's there until the end of March. And instead of when we change it and we put it in a new location on 1st of April, we would then have to configure that setting on the IoT. But because we have this placement module, we just say that this specific machine on this location is not there anymore, and it's in a new location from 1st of April. So whenever you get an event created, it depends on the time when it was created. So if it was created on 29th of March, you know that is in location A, on bar A, whatever. If it was created on 2nd of April, we know it's on a new location. So we don't need to go to every device, connect to it with USB and code the new location in, because the post REST API needs to send all the data. So it's on the Drupal side to decide and to tell where this machine is placed. So the post request looks like this. You need to define the content types. You have a body in JSON. You see now I presented the content types. You see the target ID is event if you're sending data from the machine. We have value 2, and the field clicks is 2, and the value per click is 0.5, which means we put in €1. And the target ID for the machine is pretty much the unique identifier of the machine that's sending out the data. This is all you need to know, and it's good to test this with Postman before you even put it on your device if everything is working. So we're now testing Drupal here by using Postman tool. We put in our URL, we put our body with JSON code, the JSON array, and JSON object, and the status 201 is what we get back. So everything below you see is what we get from the Drupal server, and it returns the in our case the whole node entity. tool 1 created. This is what we're looking for. This is what we're checking on our IoT device. So we have the code. We know the post is working. We know the server is working. We have the device. We know how everything works. We understand the components, and now it's time to install it. So we are going to connect it between the coin validator and the coin operating machine by using this daisy chain custom cable. Usually this is just a cable, 10-pin cable going from the coin validator to the coin op machine, but we're trying to read, we're going to be this man in the middle who's going to read the data that the coin validator is sending to the coin op machine. You can see there it's not an ideal place as it turned out, so this is one of the earliest photos. There are a lot of vibrations in specific machines, like pinball, for example, because one of the things that you want to do is to nudge it, and it was breaking off the those little edges where it was screwed in. So also, whenever you're installing something, you need to make sure that it's safe there and it's installed properly. Okay, so now we're powering it on, and we need to set up the Wi-Fi connection. This is what you get. On the bottom left, you see a printout from the serial monitor, what's going on. So you can also debug this, especially when you have it connected on your IDE. And on the right, there is a screen to see on the phone, because you usually go with this on the coin op machine, and you're on location. You boot it up. You have your phone. You don't need a laptop, and you can configure everything from your phone. You click the configure Wi-Fi button. You put in the SSID, or select the SSID from the listed ones, and you put in the password, and it stores this in on the IoT device, and Wi-Fi Manager library is taking care of that. So the next time you boot it up, it automatically connects to that SSID. The initial setup on the IoT device, this is the HTML form I was mentioning before. It has a machine ID, and we're using 306. I think this is the ID of our test machine. Credit value 50 cents, and one good thing there is the delay post. What this means is, because whenever you put in a coin, you don't want to send out the signal in the next millisecond. You want to wait, because usually there's a session the user has. If you put in, like in a coffee machine, you have 50 cents, but you want to put €2 and then click the button because you need to decide which item you want. Or if you play pinball machine, usually it says after €2 you get a bonus. So instead of 4 credits, you get 5. So you're putting in the coins for a couple of seconds, and this is the delay time. Usually it's 10 seconds. I mean, it can be 30. But just for testing, we have 10. So 30 seconds. In 30 seconds, usually the users, the users are done with inserting the coins, because you probably look for them in your wallet and you find another euro and put it in. And after that time, after the 30, or in this case 10 seconds, the machine waits for it and sends out the signal. And this is what you get on Drupal. It's a list. First of all, it's a list of all the pings, some from real machines, some from test machines. And you see, what is that? 3 days ago, I put it up at around 2 p.m. And it sent out a signal that it's now powered on. It gave me my local IP, and of course the version of the software is there, but I'm not showing this on this list. And now, if it's going to work, let's check this demo. So this is a pinball machine, about 30-year-old. This is the coin validator. You see the daisy chain cable to the IoT device, and there's the PCB on the coin op machine where it's all connected and where it's getting the power. So whenever we throw some money in, something needs to happen. And so in this case, we're throwing €2, and we get a light for every click that it did. And now we're in the delay post. It waits for 10 seconds, and in about 2 seconds, we will see clicks. Okay, we got clicks, and refreshing the page, we can see that we put €2 in on the right, on a test machine. This is how it works, and this is what we then get. So a new event created, where a total value is there, and yeah, this is pretty much all there is to it, except the ping is there on the boot, which I didn't show, not to make a video too long, but just to have a better visualization on what is going on. And the future development, the plans that I have in the future is to actually also build the power off for the ping. The challenge here is that this device is powered by the machine itself. It doesn't have a battery, and what we need to take care of here is that we need to still have some power when you power it off. So pretty much what happens when you power off the machine, especially in the film machine, it powers off the whole machine, so you don't have the power to actually send out the signal. It's like plugging the cable from the wall. And I was thinking about actually introducing a capacitor or something like that, maybe a battery, but it's probably going to be more expensive, to still have the energy to send out the signal, to still have the energy for the 2 seconds to send the power off signal. It's really good to know the power off, because otherwise you only get the power ons, and you don't really have the time, if you're doing some proper monitoring, when it was powered on, when it was powered off, because you always see maybe every morning it was powered on, but you don't know when it is powered off. So it's good data. The OTA is the over-the-air updates. This is what would be good to have, because in case I'm updating the firmware and I have new version 1.51, I need to go to the every device and put new firmware. You know, if I have changed the form, or usually I do that, but you know, let's say you change the URL of your server, you know, you need to go to the device. But the ESP allows the over-the-air updates. I did some investigation on this, didn't make it happen, but definitely something for the future, because with that you have the connection to the machine, to the IoT device. In that case, you can send a new firmware over. The push notification, why this is crossed, I actually made it happen. Also in Drupal, there's a module for that, a web notifications, or something like that. And it was just too annoying. So I disabled. So every time someone put the coin in, I was getting notification. And then, okay, I said, it works, I'll disable it. Remotely trigger credits. So this is a fun thing. On one of the previous slides, you probably noticed on the right I had credit. And I did that. You click and it actually gives you credit. So it's really fun, because you know, you can be anywhere in the world pretty much, or in the same room, and there's someone standing in front of a really old machine, and you click that button, and then it just starts giving credits, like goes around. But it's crossed out, because you know, if you have friends, they ask you to give them credits remotely. So this is not good to have. You don't want to have it. It's a good feature, it was fun, but you just cross it out the list. Priorities. Payment with cryptocurrency is one thing I wanted to introduce to this, and maybe it will happen. We'll see about the time. It would be good to actually have an option to, just for fun, you know, create something, you know, that's going to be connected with the device. You'll pay, and then it will give you the credits. So we don't use coins anymore. You can actually eliminate the coin validator in this case. You just have the device connected to the coin-op machine, and it will give credits. And graphs for ping and events data, something that you actually can do also in Drupal by just putting the data that you have in a graph like that. So I gave that graph just for the demo here to see what we could do with it. So let's say you want to read the information, you want to know when your users are active the most, when they're using those machines. And for example, you'll see that on Wednesdays nobody is there in the bar. Maybe there's a reason. You call the owner and say, well, why is Wednesdays so low? And they say, okay, they're closing early or something like that. So it's good to have the data, because otherwise you don't have a clue what your machine is doing. And yeah, that's it all for today. Thanks to our sponsors, and thank you for listening. Thank you again. Have a nice day. And now we can switch to the questions. I think there is The cube. Okay. Any questions? Sure.
That's okay. Good. Like now you know that I will never play baseball. So my question is on two things. So you seem to have like the same you use the same type for everything. So content types are those even really nodes for events and locations and placements and whatever?
Those are nodes, yeah.
Okay.
Content types nodes, yeah.
Usually I would separate the ones that I want to see on the front end into nodes, and the rest would be entities. But
yeah. I mean, I agree with that.
Probably something that's completely.
It's to pretty much, as I mentioned, just to simplify everything. If maybe I would go more professional with that, it would be better to separate. And this is not a node. This is not a content.
Yeah, it's a closed system anyway. No one has access to it. I mean, if people have access to it, you can I'd like to press the credit button.
Yeah. No, this is actually, the credit is only for specific roles. So it was admins only. So I gave the permission to a friend, but it had just a authenticated user role. So the credit column wasn't shown to him.
Yeah. And so, but my real question is on that power off. So you don't actually need a battery. Depends a bit on what you use it for. But if you wanted to have an idea of what's turned on and off, you can probably have like the machine ping your system every time saying I'm alive every hour, and then you'd have like hour or half an hour granularity, and you could store actually like every 30 seconds something inside your own
I was thinking about this. I had it in one of my notes to actually ping the device every 5 minutes. I don't like the sound of it, even though I know this is quite common. But the power off thing was, maybe more of a challenge. But I know it doesn't probably sound that good in case you still actually do it in practice.
If you want like way down granularity, you could have the machine stored in its internal configuration every time that it loops. I'm still alive. I'm still alive. I'm still alive.
Yeah.
And then the next time that it boots, it would actually transmit back to you the last time that
that's a good idea.
That it was
that's a good idea.
Knew it was alive.
So you would only know it the next time it boots, but you'll have good data. But yeah, it's a good idea. Thanks.
Something like that. And then you'd avoid having a battery, which is really expensive. And batteries die.
Yeah. Of course, this is
batteries can actually burn.
Yeah.
so it would be something way easier and cheaper. And
okay. Thanks.
Only. Any other questions?
Sure, there are. Good catch.
I wish my production projects were that clean. So yeah, then it was really cool.
Thanks.
How much time did you spend on this?
Okay, so it was my summer project. I had 2 months of time, but in those 2 months, it was like a couple of days when I worked 2-3 hours, a couple of days off. But it was a span of 2 months. But probably can be shrink down to a month, because it was a summer project and I did it just for fun.
Do you plan on doing something in prod from the? Is it your test bed for something bigger or
no,
just
not really, because if we're talking about something bigger, we probably talk about selling this, creating actually a product, delivering for that. You need a bigger team, you need support, it's software, you need manuals, installations, you need really a proper team for that. It's not a one-man band if you want to distribute it and start selling it, because once you start doing that, especially if you're really picky, you don't want to deliver something that's not going to work in a year because of some firmware updates. So you get a lot of calls, or I want to return this device, it's not working, it's pretty much just for testing, just for fun, but it's something that can be built in a bigger thing, have a team. Yes.
Yeah. Okay. Thanks for the presentation.
Yeah. Thank you.
Hi. Have you started using Tasmot instead of your custom firmware in the ASP?
Sorry, what's that again?
Tasmot, have you started using that instead of the custom C++ code?
No, I heard of it, but no, I haven't checked it out.
Okay, that's a good SDK.
Yeah,
it's in your coin operator, but you could use your knowledge in hundreds of other IoT devices, and Tasmot using the ESP can give you a broad spectrum of devices.
Okay, so it would be better than C++.
Yeah, of course you would also to do some custom code to integrate with the machine, but Tasmot gives you the Wi-Fi, the MQTT stack, and the other stuff like that. That it could be quicker to develop and broader to other devices.
Okay, thanks. My excuse here is that I wanted to make it as a learning experience. Decision C++. Okay, let's go for it. So sometimes I want to make my life harder or more difficult. And try to solve more challenges or get or put myself in front of new challenges. So sometimes you don't always go with something that's maybe the best or the easiest solution. But sure. Thanks for the suggestion.
No problem.
Any more questions? I think we're on time. It's 11:50. Okay, thank you everyone for coming. If there are any other questions, you can look for me around the place. I'm still here for the whole day. And as I said before, have a nice day. Have a nice Drupal Dev Days. Thank you.